Hi, this is Dan Omsby from Sparkgeo with an update on the application that we're building on the hub that combines climate projections and observations data. To recap, our solution is based on providing a web tool that will help organisations assess how their assets might be exposed to risks from climate change, in particular chronic heat. First, we're using the workflow runner on the hub to generate a number of hazard indicators from climate projections, which provide a simplified set of metrics that can be used in risk assessments. For example, we calculate the number of days per year where the average temperature exceeds a particular threshold as a measure of chronic heat, and produce these for a range of climate projection data sets, warming scenarios and years. We started with CMIP6 projections, but have since onboarded the Met Office UKCP data, ranging from global 60-kilometre data down to the 2.2-kilometre UK data sets. We're currently liaising with the Met Office over incorporating a beta data set of bias-corrected projections, which will be an exciting development. Projection data is of course limited in its spatial resolution. Whilst impacts such as the urban heat island effect can be detected in projection data, the insight from historic observations, for example from land surface temperature data, comes into its own. We've onboarded some daily observations data from the University of Leicester's work on land surface temperature. Here, a downscaled product at 100-metre resolution illustrates what was happening in London in the heatwave of July 2022, where you can quite clearly see the differentiation between the areas where there are cooling features such as the river and vegetation and large open spaces, compared to those with dense buildings. Our application then provides tools for users to compare their asset portfolios against these datasets by running workflows on the hub. Here we're loading up a sample asset dataset of 200 randomly selected schools in London. A fairly simple workflow is a land surface temperature analysis, which provides a lookup for each of those assets against the LST datasets, allowing the history of observations at that asset location to be easily determined. A couple of minutes later, the results are returned in a format that can be viewed within the application as simple tables and charts, or downloaded for further analysis into a third-party package. Another workflow example for assets, which is far more sophisticated, incorporates the physical risk and resilience models developed by OS Climate, the open source foundation project. Here, we're loading up a sample dataset of 200 industrial sites around the world and running the OS Climate Phys Risk model on those assets. Based on the type of asset, these run a range of risk assessments, including chronic heat, but also impacts such as coastal and riverine inundation. For chronic heat, this will look at the impact that the heat has on the workforce, return back a set of metrics based on reduced productivity as a fraction of hours lost per year for heavy industrial work, across a range of different warming scenarios and years. We're currently discussing with the OS Climate team how best to represent this data in the user interface in a way that is more intuitive to end users. But the workflow we've got here is already doing the heavy lifting. Hopefully that gives you a bit of an insight into where we have got to with our developments. We would like to engage more directly now with interested stakeholders, so if there are follow-up discussions you'd like with us, please do get in touch via the Hub team. Thanks very much.